Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the CT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 27 of mathematical physics, and in which I'm going to discuss Fourier series. Okay, and also I would request to the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start the Fourier series. Okay, Fourier series. Meanwhile, just let me check whether am I audible or not. I'm just checking, guys. Just give me some time, okay? I hope I will be audible. I'm not able to check at the moment. I'll, each periodic function, each periodic function can be written as can be can be written as a function of as a function of cos x periodic function. Each periodic function audible can be written as okay can be okay. So each periodic function can be written as function of cos x or sin x. Okay, if its function is periodic, sin x. Okay, and fx we can write it as a naught by 2 plus sigma n equal to 1 to infinity. Okay, a n cos nx plus bn sin nx. Okay, so we can write in this form any periodic function. Okay, fx equal to a naught by 2 plus sigma n equal to 0 to infinity a n cos nx plus bn sin nx. Okay, so where a naught is known as reference level, and a1 and b1 a1 and b1 are known as harmonic first harmonic. Okay, first harmonic. A1 b1 first harmonic. Well, next point. So here you can show it, right? Like uh, if 0 to 2 pi, okay, the limit is 0 to 2 pi and 2 pi, or limit is minus pi to pi and 2 pi. Okay, 0 to 2 pi means the period is 2. Minus pi to pi means period is 2 pi, and this is also 2 pi. This is going to be like in graph we can represent like this. Okay, this one, and for this it is going to be Okay, so this is the graphical representation. Okay, so now and 0 to 2L, okay, fx dx, and value of uh, an is going to be 1 upon L 0 to 2L fx sine bn is going to be, this is 1 upon L, this is the period, okay, 1 upon L uh, 0 to 2L fx sine nx dx, okay, and here the limits are like this one, minus L to L, that is period is 2L, okay, and 0 to 2L period is 2L, okay. And similarly if the period is like minus 2L to 2L, then period is going to be 4L, okay. So this is the brief idea how to get the Fourier function, okay. Okay, Fourier Fourier series, okay. So now next point is, if fx is periodic function, fx is periodic function in the interval, in the interval in the interval 0 to 2 pi, okay. So the fx is periodic function in the interval 0 to 2 pi. In that case 0 to 2 pi fx dx is going to be 0 to 2 pi a naught by 2, okay, plus sigma n equal to 1 to infinity n equal to 1 to infinity, and that is an cos nx plus bn sin cos nx dx, okay, plus bn integration sin nx dx, okay, this one, this value, okay. So further we can write, this is a naught, a naught by 2, a naught by 2, and this is this value is 2 pi plus sigma n equal to 1 to infinity, n equal to 1 to infinity, so this is an sin nx upon n 0 to 2 pi, okay, 0 to 2 pi, 0 to 2 pi, okay, this one, plus bn minus cos nx upon n 0 to 2 pi, we can write this, okay. Now we'll compare, okay. So this is 0 to 2 pi fx dx, okay. Now comparing both sides, comparing both sides, if we compare both sides, so this is going to give this one, 0 to 2 pi fx dx is going to be a naught pi, right. This is a naught pi, 2 will get cancelled, a naught pi, and from here value of a naught is going to be 1 upon pi 0 to 2 pi fx dx, okay, important part. Similarly similarly an is going to be fx cos n pi x dx, okay, this is the an. important one. Okay, and similarly Bn is going to be 1 upon pi 0 to 2 pi fx sin n pi n nx, not pi, nx, right? Okay, nx dx. Okay, this is the one. So Bn equal to 1 upon pi 1 upon pi fx sin nx dx. Okay, this one. These are the values. Next is if this is the if limit is between this, I have explained if limit is between 0 to 2 pi. Suppose limit is between 0 to L, 0 to 2L. Okay, there is a function fx whose limit is in the limit 0 to 2L. Then what will be the case? Okay, 2L. 2L. Okay, so in that case, if this is the case, so change of scale, right? This is change of scale, and in that case, value of fx is going to be, so we can write fx, this we know, right? A naught by 2 plus sigma n equal to 1 to infinity fx n equal to 1 to infinity an cos nz plus bn sin nz. Bn sin nz. Okay, so from here, because here we know 2 pi x 2 pi x is 2lz. Okay, so from here the value of z is going to be pi x upon l. Okay, very important. This is change of scale, guys. Okay, so z value is n pi x upon l. Okay, so now the value of an is going to be 1 upon first value of a naught. Value of a naught is going to be 1 upon l integration 0 to 2l this is going to be fx dx. Okay, value of an is going to be 1 upon l, change of scale. Okay, 0 to 12 fx and cos n pi x, because n pi x upon l, because value of z is pi x upon l, this one. Okay, this one, pi n x, this cos n pi x upon l dx. And similarly value of bn is going to be 1 upon l integration 0 to 2l fx sin n pi x upon l dx. Okay, fx sin n pi x upon l dx. These are the values if we change this scale. Next, even function. Okay, if even function is there. Okay, even function fz is even function. So in that case, if even function means f minus x equal to fx, right? This we know, f minus x equal to fx, even function. Okay, and interval is minus pi to pi. Okay, interval is minus pi to pi. So in that case, a naught value is going to be, so I'm talking about even function, guys. Okay, so a naught is going to be 1 upon pi minus pi to pi, okay, fx dx, right? Or we can because it's an even function, right? So we can break the limit. So this is going to be 2 upon pi 0 to pi fx dx, we can write it. Okay. Similarly, value of an is going to, for even function I'm talking about, okay, so 1 upon pi minus pi to pi and fx cos nx, okay, cos nx. This value, because here this value is going to be 2 upon pi 0 to, even function is there, right? 0 to pi, cos is even and fx is even given, right? So this is 0 to pi fx cos n pi, my apology, this is nx dx, okay. So and bn is going to be 1 upon pi minus pi to pi fx sin nx dx. Okay, so this value is going to be 0. Why? Because this is odd function and this is even function. Okay, even and odd multiplication is gives the 0 value. Okay, so because this is odd, this is even, means integration is going to be 0. So for we can write for even function, for even function for even function bn equal to 0. So we can write if even function is given, so bn equal to 0, right? So will not take bn functions. Okay, bn will not calculate bn values. Okay, because that is going to be 0 for even function. Very important thing, guys. You need to note down. Next is for odd function. Okay, for odd function, for odd function, for odd function, we know f minus x value is minus fx, right? And here for odd function, an equal to 0 and a0 equal to 0, guys. So you need to note down. So what if it's an odd function, then these values are going to be 0, and only we'll take bn values and will not consider an and a0 value. So bn is going to be 1 upon pi integration minus pi to pi, okay, fx sin nx dx, okay. And these are ordered functions, so this is going to be 2 by pi, will break this minus in fine, this is going to be, will break the limit, so this is going to be 0 to pi fx sin nx dx, okay. So this is a odd function, so this is going to be 2 upon pi 0 to pi fx sin nx. Only will consider bn values, and an and a0 values are going to be 0 for odd function. Okay. Well, now I'll solve question. Now I'm going to solve the question. Okay. Question is, fx equal to k if x is between 0 to pi, okay, and fx value is 0 if x is between 0 to 2 pi. Okay, if this value is 0, if x is between 0 to pi to 2 pi. Okay, and between 0 to pi the value is, okay. So this is the one. So you need to find out Fourier series of it. Okay. Well, so first we'll find out, because we know Fourier series expansion, right? So we'll find a1 a naught first. Okay, a naught is going to be, we know, 1 upon pi, 0 to 2 pi, 0 to 2 pi, right? 0 to 2 pi fx dx. So this is going to be 1 upon pi, 0 to pi, which value is k dx, plus pi to 2 pi. This value is 0, because k value is fx is 0, okay? 0 dx, right? So a0 value is going to be 1 upon pi, and k 0 to pi plus 0. So a naught value is, this is pi upon pi, right? Pi. Yes. K will be outside, right? Yeah. K will take constant, right? This is x. Okay, so this is going to be k upon pi into pi. So this will get cancelled. So a naught value is k. A naught value is k. Similarly, we'll find an. An value is 1 upon pi, 0 to 2 pi. Okay, k cos nx dx. Right? So this value is going to be 1 upon pi, 0 to pi. 0 to pi value is k cos nx, plus 0 to 2 pi value is 0 dx, because there is 0, right? Because fx value is 0 for this limit, which is given in the question, guys. Here, this one, okay. So this is going to be 1 upon pi, k will be outside, and cos integration of cos nx is going to be, sin nx upon n, 0 to pi, and this value is, so sin pi equal to 0 and sin 0 equal to 0. So this value, an value is 0. Okay. Next is bn value. Okay. So bn value is going to be, that is simple, 1 upon pi, 0 to 2 pi, fx sin nx dx, right? So this is 1 upon pi, 0 to pi, k sin nx dx, plus 0 to, okay, my apologies, pi to 2 pi, right? This value is 0. So this is going to be k upon pi outside, sin x is minus cos nx upon 0 to pi. Okay, so we'll put the value. So this is going to be k upon n, and the value is cos pi. Cos pi value is -1 and minus plus, right? So this is going to be cos n pi. We'll take minus common. Okay, so this is going to be cos n pi minus cos 0. Okay, cos n pi value we know, that is going to be bn, right? Or we can write bn equal to minus k upon pi. We'll take minus out inside, so this is going to be 1 minus 1 to the power n. Okay, this one. This is the value, because cos n pi. Now for n equal to here, and right, for And now you can see, if for minus 1 to the power n, this value minus 1 to the power n value is going to be 1 for n equal to even value. Okay, even value. If n are even value, even integer, right, even value, then this value is going to be 1. Okay, if n to the 1 minus 1 to the power n equal to going to be minus 1 for odd value, for odd n, right? This one very important thing. Okay, so this value is 1. So here if this value is going to be 1, right, then this complete value is going to be 0. Okay, and if this value is going to be minus 1, then this complete value is going to be 2 pi. So bn equal to 0 for n equal to 0 to 4, right? And bn is going to be, bn value is going to be 2k upon, bn value is going to be this one, k upon pi 1 plus 1, because if this value is going to be minus 1, so minus 1 minus minus plus, right, this is going to be 2k upon pi. Okay, so bn value is going to be 2k upon pi for n equal to odd, means 1 3 5 so on, right? Very important point. Okay, so now we'll write this we'll write the function fx Fourier series. We know, right, the formula of Fourier series is, this is a naught by 2 plus sigma n equal to 1 to infinity an cos nx plus bn cos bn sin nx. So fx is going to be this one, and now we know the value of a naught value I have already found, that is a naught value is k, right, and a naught a1 value is 0, right? This is going to be k by 2 plus here sigma n equal to 1 to infinity. Okay, and this is going to be an value is 0 plus bn sin nx. Okay, now bn value, we know fx bn value is 2k by pi n equal to 1 2 3 5, and if even values are there, then value is going to be 0. So we can write k by 2 plus, this is going to be b1. So bn value is this, which is 2k by pi, right, 2k by pi. Okay, and this is going to be 2k by pi, will take common bn, right, 2k by common, and sine values and for sine, we know this value is only for odd values, so this is going to be sine 1, right, sine x plus sine x upon 1. Okay, because 2 pi by n is the value, right here, 2k upon n pi, 2k upon n pi, it's, n is also there, guys. Okay, how? Because here n is there, right, because n is there, so this is n. Okay, so this is going, will write 2k upon n pi, right, that is 2k upon n pi. So 2k will take common, will take 2k upon pi common, and this is going to be this, and then sine 3x upon 3 plus so on, right? This is the going, this or this is the value, right? And also we can write one more term, this is going to be sine. So this is going, the value of fx is going to be, now fx is going to be k by 2 plus 2k upon pi, right, and this we can write it is the same, sin x upon 1 plus sin 3x upon 3 plus sin 5x upon 5 plus so on. Next is suppose if if value of x equal to pi by 2. Okay, value of x is pi by 2. So right now this is going to be f pi by 2 value, right? F pi by 2 is going to be k by 2. This is the answer, guys. Okay, this is the answer. And so suppose if value of x is pi by 2, so this value is going to be k by 2 plus 2k upon pi sine pi by 2 upon 1 plus sine 3 pi by 2 upon 1 plus sine 5 pi by 2 upon, this is 3, this is 5 plus so on, right? So these values are going to be then f pi by 2 values, this is a constant function fx, right? So this is k value is given, right? This is k by, this is k by 2 plus this is 2k by 5, and this value sine pi by 2 value is 1. Okay, minus sine 3 by so so sine pi by 2, sine 3 5 pi by 2, sine 9 11 pi 9 pi by 2, these values are going to be 1, and sine 3 pi by 2, sine 7 pi by 2, right? Sine 11 pi by 2 value is going to be minus 1. Okay, so this is minus 1 by 3 plus 1 by 5 plus so on. Okay, and kk will get cancelled from here. Okay, and we will take k this side, and this value is going to be 1 by 2, 1 by 2 I have taken this here, and kk get cancelled, 1 by 2, and this value is going to be 2 upon 5, k get cancelled. Okay, 1 minus 1 by 3 plus 1 by 5 plus so on. Okay, this is also the answer. Or we can write no, we can also simplify it further. So this is going to be, we can directly write this pi by 4 is going to be 1 minus 1 by 3 plus 1 by 5 plus so on. Okay, so this is the one. And also guys, I'll tell you one trick. Okay, so okay, so now I'm going to solve question which is asked in TIFR. Okay, TIFR question, which is asked in TIFR. Okay, question is fx value is given sigma n equal to 0 to infinity. Okay, so an cos nx plus bn sin nx. Okay, bn sin nx. Okay, so n equal to 0 to infinity an cos nx plus bn sin nx. So this is the value given. Okay, so and also f1x is given cos square x, and that implies a21 comma a22. Okay, similarly f2x is given, that is sin square x, and that implies a22 and a22 and b22. Here we have made mistake. This is b21. Okay, so this is given a21 b21, and this is a22 b22. Okay, so this is given, and options are given. So we have to select the correct option. Okay, a21 is 1 by 2, B21 or B22, my apology, B22 is minus 1 by 2, minus 1 by 2, and option B is B21 equal to 1 by 2 and A22 is minus 1 by 2. Okay, and option C is A21 is 1 by 2, A22 is minus 1 by 2, and option D is B21 is minus 1 by 2 and B22 is minus 1 by 2. Okay, so these are the options. These are the options which we have been given. Okay, so I'm going to solve it. So here these are given, right? This is the function, and which option is correct, which we need to find. So here you can see we have been given, since cos square x equal to, we know cos square x is always even, right? So even function, it means a should be the there should be value of a and b should be 0. Okay, and similarly sine square x is also even, because sine square x means sine x whole square, right? This is also even. It means this is even, means a should be, there should be value of a and b should be 0, right? So let's see which option is matching. So here you can see option C. You can, if you check option C, so here you can see there is a A21, there is a value. Okay, A22 there is a value, right? But there is no B1, B2, right? So it means this is the correct answer. These are 0, right? So option C is the correct answer, right? Okay. Okay, so option C is the correct option, because from here you can see we have cos square even, and this is even. Even means A should be, there should be value of A and B should be 0, right? B is 0, that B and value should be 0. So these values are 0. A value there. So here you can check. There is A value, there is B value. This cannot be up to, because B is all 0, right? Here B value, this is not correct. There B is value correct. So A2 value, A21 value, and A22 value is given, and so B is 0, obviously. So A2 and this are given, right? These are the values. So option this is the correct. Option C is the correct. So it's a TI5 question, guys. I would suggest you practice it. Next. Next is complex Fourier series. Okay, complex Fourier series. Complex Fourier series. Okay, so here fx is going to be in complex Fourier series n equal to minus infinity to plus infinity. Okay, minus infinity to plus infinity. Cn e to the power iota n pi x, iota n pi x by 2. Okay, so this is the Fourier series of this fx values, Fourier complex Cn e to the power iota n pi x by 2. N pi x is an plus ibn by 2. Okay, so this is the value of an. You can find an plus ibn by 2. This is the value of c1 cn. Okay, or value of cn is very important. 1 upon 2 pi integration 0 to 2 pi, integration 0 to 2 pi, 1 upon 2 pi integration 0 to pi fx e to the power minus iota n pi x upon L, minus iota n pi x upon L dx. Okay, this is the Cn value. Well, from here also we can write fx mod square of fx is going to be, this we know, mod of sigma n equal to minus infinity to plus infinity cn e to the power iota n pi x upon l, n pi x upon l mod square, right? Because here because value of fx is this, so we can take mod square on both sides. So mod of fx square is going to be mod square of sigma n equal to minus infinity to plus infinity, okay, cn e to the power iota n pi x by l, okay. So from here, integrating both sides, integrating integrating both sides integrating both sides, okay. So this is going to be 0 to 2 pi mod fx square, mod square of fx, mod square of fx dx is going to be integration 0 to 2 pi mod of sigma n equal to minus infinity to plus infinity cn e to the power iota n pi x upon l mod square, okay. We can do like this. So we have integrated both sides, okay. So this value is going to be sigma uh, integration 0 to 2 pi, this we can write cn star cn, right? Mod cn mod square of cn is cn star cn, and we can write e to the power iota n pi x upon l, n pi x upon l into minus iota n pi x upon l, right, and dx. So this value is going to be, and this value is going to be implies sigma n equal to minus infinity to plus infinity mod cn square. This value is going to be, okay, this value is going to be 1 upon 2 pi 1 upon 2 pi integration 0 to 2 pi integration 0 to 2 pi fx mod square mod square of fx dx, okay. This is also important. So sigma n equal to minus infinity to plus infinity mod square of cn is going to be 1 upon 2 pi 0 to 2 pi f mod square of fx dx, okay. Well, so I'll solve one more question here, which is asked in TIFR, okay. Asked in TIFR, okay. Question is the coefficient of coefficient of e to the power I kx, coefficient of e to the power I kx in Fourier series, expansion, in Fourier series expansion, the coefficient of e to the power I kx in Fourier series expansion, and the interval is given minus pi to pi, okay. In for Fourier series expansion of ux equal to a sine square alpha x for value of k is minus 2 alpha is okay, and interval is given minus pi to pi and alpha is integer alpha is integer and options are a by 4, option B is minus a by 4, option C is a by 2, and option D is minus a by 2. Okay, so this is the question, guys. Coefficient of e to the power I kx you need to find out in Fourier series. Expansion of ux is given a sin square alpha x, where k of for k is value of k is 2 alpha minus 2 alpha. Okay, the interval is minus pi to pi, and alpha is integer. Okay, this you need to find out. So coefficient of e to the power I kx, right? So this we need to find. So ck we need to find out, and ck value we know that is 1 upon 2 pi, 1 upon 2 pi minus pi to pi a sin square alpha x e to the power fx, right? A sin square alpha, this value I have already shown you, this one value of cn equal 1 upon 2 pi 0 to 2 pi fx e to the power I minus iota n pi x by 2, right? So this is going to be minus iota ikx dx, right? So this is going to be value of ck is going to be a upon 2 pi, we can take common, and this is going to be minus pi to pi sin square alpha x e to the power minus iota kx dx. Okay, so value of ck is going to be a upon 2 pi, and this going to be integration minus pi to pi, and this value is going to be, this we can write, okay, e to the power uh, alpha x plus e to the power minus alpha x by 2, and this is by 2i whole square, we can write, right? Here the sin alpha x value is e to the power alpha x plus e to the power minus alpha x upon 2i, we can write it. Whole square is whole square, right? And this is going to be e to the power iota kx dx. Okay, so value of ck is going to be a upon 8 pi 8 pi minus 8 pi, right? Why it is 4 pi 4 I square, will if you open this square, right? 4 pi 4 I square, 4 to the 8, and I square value is minus 1. Okay, and so this is going to be, we will open it, and we open it, so this is going to be integration minus pi to plus pi, and this will open it, so this will e to the power iota, this is iota, guys. Okay, iota e to the power iota 2 alpha x plus e to the power iota e to the power minus iota 2 alpha x, and minus plus 2, this is minus, guys. Okay, so because it's a sign, right? So this is minus, and this will be whole square is going to be minus 2, and e to the power I alpha x, e to the power minus I alpha will x will cancel each other, right? Into e to the power iota key value is minus, this is minus, guys, right? So this is value of k is minus 2 alpha, so minus minus plus means 2 alpha x, 2 alpha x. Okay, iota 2 alpha x, since k is minus 2 alpha, we have put the value. Okay, so value of ck is going to be minus a upon 8 pi, and we'll integrate it right now. Okay, so this is going to be, will what we have, we can multiply this, so it is going to be minus pi to pi, very important, minus pi to pi, and this is going to be e to the power minus e to the power iota 4 alpha x plus e to the power minus iota 4 alpha x minus 2 e to the power, this one 4 2 to the 4, right? 4 alpha x minus 4 alpha x, this is 2 e to the power minus iota alpha x 2 alpha x 2 alpha x dx. Okay, this is plus, guys. Okay, plus will be there because this plus, so this became plus, right? Well, so now very simple. Now we'll solve it, right? So dx and these are alpha x. So this is going to be, so this is going to be, will integrate it. So minus a upon 8 pi minus a upon 8 pi, and this value is going to be x plus e to the power iota 4 alpha x upon 4 iota 4 iota 4 iota alpha. Okay, and minus 2 e to the power iota 2 alpha x upon 2 iota alpha, and this is minus pi by 2 minus pi by 2 pi by minus pi to pi, right? So this value is going to be minus a upon 8 pi. This is going to be pi minus pi, pi minus minus pi. Okay, pi minus minus pi, and plus this is going to be 1 upon 4 iota alpha 1 minus 1. This value is going to be, okay, 0, and this value is 1, right? Minus 2 will get cancelled, 1 upon iota alpha, and this value is going to be 1 minus 1 after putting the limit, right? So this is going to be uh, minus a upon 8 pi into minus minus plus 2 pi, right? So this value is going to be 2 will get cancelled, pi will be minus a by 4. Okay, minus a by 4 is the answer. Which option is matching, guys? Let's see. Minus a by 4. Option B is matching, guys. Option B. Option B. Because it's a minus a by 4. Okay, guys. Well, this is about the Fourier series. Okay, so guys, we'll solve some more questions as well. Okay, so guys, before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help the students to crack their examinations related to physical science. Okay, guys. Thank you. Bye now.